Hello, how are you? I hope you are doing well. So, today we are going to continue lecture number 4, research methodology, and we continue to quantitative approach. In the previous lecture, we have discussed about the qualitative approach, and today we talk about quantitative approach, and we continue all our other lecture classes based on the quantitative approach. So first thing, we need to define what do we mean about quantitative research. What is it? It is defined as a formal, objective, and systematic process in which numerical data are utilized to obtain information about the world, and a research method which is used to describe and test relationships and to examine cause and effect relationship. And this based on uh, Burns and Grove 1987. So from that definition, we can make it in simple way. Quantitative research is a systematic scientific investigation of data and their relationship. I would like to emphasize here that in qualitative research, we use words, and we have learned that we have something like domain, categories, and teams. But in quantitative research, we use numerical data, numbers, and most probably here we are talking about variables or constructs rather than teams and categories as discussed in qualitative. So again, I would like to remind you that this is a deductive approach, and it is from top to bottom, which is opposite of inductive approach, from general to specific. So the first thing, researcher test or verify a theory. You will take the theory, you observe a phenomenon, you apply a theory to explain that phenomenon, to explain the relationship between the variables. And here, after you will test those theories by developing hypothesis or research question from the theory. After that, you will define and operationalize your variable derived from the theory. You collect the data, you measure those variables using an instrument or to obtain scores like a questionnaire. And after you collect the data, you analyze the data, and you come out with a conclusion. And what are the elements of quantitative research? We have first, we test an experiment under a controlled condition. We will see later a cause and effect relationship. Also, we will talk about it later. Gathering numerical data objectively. Results lend themselves to statistical analysis, which is not like a qualitative one. And evaluation of the result confirm or refute the original hypothesis that was developed from the theory. At the end, you will say, this study confirmed that hypothesis, therefore confirm the theory, or refute it or reject it. So, making sense of quantitative studies, first you think about the sample size or the sample. Who does this represent? If you want to study about, education, maybe your sample are students, maybe are teachers, maybe are lecturers. Read the method section. How did they create the measures? I mean that previous studies that you rely on in order to measure also your variables. How they measure those variables? Do you believe that the measures represent the intended concept or no? And that's later also we will talk about that. What are the potential confounding variables? And also we are going to talk about that later. Think about a generalizability of the study. Can you generalize this study or no? Think about whether the analysis is claiming to be a test of causality. What was the method used? How is causality established? Also, we'll see later. Interpretation matters just as much as quantitative study as the qualitative study. How you interpret your result. So we have some strength of quantitative research. The first one, you can manipulate your numbers to create a visual image. Example, a graph. Manipulating numbers does mean we don't. I don't mean about manipulating the numbers is you change the numbers, but you may, for example, change the 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 the, the measurement, changing, the coding, the way of coding. So for example, age, you may give age like open question 20, 25, but if you want to graph it, you may put them in categories. For example, number one, if age between less than 20, number two between 21 and 30, and you can change it. Maybe number one is less than 30, number two 31 to 50. So you can in that way manipulate your numbers, but you do not change. Someone, he say his age is 20, you manipulate and put it 25. No, that cannot be. Concept can be measured and directly compared to previous subsequent work. There may also be a direct correlation between cause and effect, and this we will see later. It may be possible to generalize towards an external validity, i.e. the predict, we will see later, and a breadth of coverage of a big population, also we will see later how big the population, or you can choose the sample size that represent that population, and we come with a conclusion. But also it has some weaknesses where the whole may not be equal to the sum of the parts. So when we take a sample of that represent the world population, that we could be biased in choosing our sample, and therefore they may not represent the world population. For example, we want to study stress among students, and we take, for example, Utah student as a sample to represent the whole Malaysian student. Maybe Utah students are too much loaded in term. We have 3 trimesters, much time, to rest and to refresh. So they most of the time they are more stressed. So if we generalize that to all students in Malaysia, maybe other in public university, they have only 2 semesters, they are more relaxed on that. So lack of depth, looking at just one part of the world. And here, for example, a simple example, when you have a correlation or a relationship between 2 variables, you know that there is a relationship, but you don't know in depth exactly why this relationship and how this relationship, is constructed. Defining everything in terms of numbers also is risky when dealing with human, especially, right? Not everything, we can translate to numbers. Ultimately, everything is qualitative. Then what are the differences between qualitative and quantitative? So in qualitative, as we seen earlier that in the last lecture class, we have multiple realities, because people, they tell you so many stories. You have so multiple realities. But in quantitative, you have only one single reality. If you want to establish a relationship between 2 variables, that relationship could be positive or negative or no relationship. Cannot be 3 of them. Reality is socially constructed, because that reality you will get it from the social, or you get it from people themselves. They give you these stories. But here in quantitative, reality is objective, because based on objective conclusion, where you use numerical data to come out with a conclusion. Here in qualitative, reality is context interrelated, but in quantitative is a context free. And in the qualitative, it's holistic. We talk about the whole, but in the quantitative is reductionist. So we go from the top or general idea and deduct, and we go to a specific. In qualitative, a strong philosophical perspective, because we used a lot of philosophies to create those theme codes and categories. But in quantitative, a strong theoretical base, we just based on the theory to develop our hypothesis, and therefore we come out to a conclusion. In qualitative is reasoning in deductive. Just now I explained, we go from specific and go to the general. We observe a phenomenon, then we generalize it, we develop theory. But in quantitative is reasoning in deductive way, and inductive way also could be in quantitative. Then discovering of meaning is the basis of knowledge in a qualitative, because we don't know much about the phenomenon, we want to discover that. So this is the meaning. But in the quantitative, mostly we would like to see what is the cause and effect relationship, is the base of knowledge. In the qualitative, mostly we develop theories, but in quantitative, we test these theories. In qualitative, theory developed during the study, but in quantitative, theory is developed priorly. Means that in quantitative, we already have the theory and we use it, but in qualitative, no. It is developed during the study, we develop it. In qualitative, the meaning of concept, we use the meaning of the concept. People, they tell us stories, and we take the meaning and we develop categories and the themes, that concept. But in quantitative, the measurement of the variables. We have the variable and we measure it. For example, poverty. How we measure poverty? Maybe poverty line, income. In qualitative, the process-oriented means that we follow our informant, our respondent, to drive us to a conclusion. But in quantitative is outcome-oriented, because, as I said, we have the theory and we develop a hypothesis based on that theory. So we will say that the more income, for example, the higher purchases. So we already established that relationship. So we are already driven by that one. So what we mean oriented, I don't mean about it like I must find a positive relationship, but I know that I'm going to test the relationship between these two variables. In qualitative, control and important, you don't need to control the variables, but in quantitative, control of the variables is very important, and we see that later. In qualitative is a rich description, because your informant or respondent will tell you a lot of experiences, a lot of stories. But in quantitative is precise measurement of the variable. So if you have a variable, you must take a very precise measurement for it in order you can do it. If the variable is broadly measured, you cannot do it. And in qualitative, the basic element of the analysis is words, but in quantitative, the basic element of analysis is numbers. So in qualitative is uniqueness, but in quantitative is generalization. And in qualitative, trustworthiness of the finding is more trustworthy, because we get that information from real life, from real experiences. But in quantitative, we have a control of error, because we are dealing with numbers. Then we have three sources, to collect the data for quantitative. The first primary source, like lab reports, record of the result of an experiment. You have field notes, measurement, etc., record of observation of the natural world. You have conference proceeding, scientific gathering together to present their work. Then you find their latest finding, ideas, articles of original research like published in peer-reviewed journals, dissertation, thesis, patent, internet website like website that publish the author's finding of research. You should know also the use of extreme caution when using the internet as primary source. Remember, anyone with a computer can put up a website, so that information could not valid anymore or could have some doubt. So if you want to use internet, you have to be very crucial. For example, if you are using internet, you're taking information from Times, it is a magazine, very well-known magazine, then it's fine. But if you are taking from blog or someone written it, he may be not that objective. So you have to be very aware of that. Second is secondary sources, where it is books, articles, and other writing by scientists reporting their work to others. Summarizing means that summarizing other people's works. Also, they may be reporting the result of their own primary research or critiquing the work of others. And these sources are usually the focus of literature review. This is where you go to find out in detail what has been and is being done in that particular research area, and therefore to see how your work can contribute to the field. What is the difference between your work and their work? How your work is going to add value, to the existing knowledge. And tertiary resources like summaries, introductions, like encyclopedia, dictionaries, textbook, yearbooks, and other sources that provide an introduction or summary state of the art of research in a subject area covered. Also, we have database indexes where they are an excellent way of finding books, articles, conferences, proceeding, and other publications in which scientists report a result of their research. So, what are the focus of scientific studies? So, scientific studies tend to focus on one or the other of two major activities here, which is the first activity consists of exploratory data collection and analysis, which has two aims. The first is classifying behaviors in a given research area. For example, social psychologists interested in studying aggression may classify aggression into several categories. For example, hostile aggression, instrumental aggression, suction aggression. And the other aim is to identify the variables involved in explaining the behavior of interest. And here I can give an example like anger may be an important variable leading to aggression. So having identified anger and aggression as a potentially important variable, you as a researcher or a scientist will investigate their relationship. Also, the second we have major activity is hypothesis testing. Hypothesis testing consists of forming tentative explanation for a behavior and then testing those tentative explanations. For example, you may hypothesize that anger causes an increase in aggressive behavior, and you then set out to test this hypothesis. Developing testable explanation allows you to predict the relationship you should or should not observe if the explanation is correct. So put in mind that hypothesis testing usually begins after you have collected enough information about the behavior to begin developing supportable explanation. And how you can develop hypothesis, as we say, you are dependent on theories and previous empirical studies. Then we have a causal relationship. In a causal relationship, one variable directly or indirectly influences another. In other words, changes in the value of one variable directly or indirectly cause changes in the value of the second. So, for example, if you accidentally drop a brick on your toe, the impact of the brick will probably set off a chain of events. Before you scream because of the pain, there is some event that you may not even notice. For example, stimulation of pain receptors in your toe, avalanche of the neural impulses traveling up your leg to your spinal cord and form there your brain, registration of the pain in your brain then involuntarily you scream. So here, although there are several intervening steps between the impact of the brake on your toe and the scream, it would be proper in this case to conclude that dropping the brake on your toe causes you to scream. So this is because it is possible to trace an unbroken chain of a physical influence running from the initial events to the final result, which is screening. So a causal relationship also can be unidirectional, in which case a variable A influences variable B but not vice versa. Means B will not affect A. The impact of the brake, for example, may produce you to scream. But screaming does not cause the impact of the brake on your toe. So they also can be bidirectional, in which uh, each variable influences the other. Everything else being equal, for example, reducing the amount of exercise a person gets lead to a weight gain. But also in the same time, because of the increased effort involved, heavier people tend to exercise less. Thus, exercise influences body weight and the body weight influences exercise. So, in two ways. Then I would like also to emphasize that simply observing that changes in one variable tend to be associated with changes in another is not enough to establish that the relationship between them is a causal one. If a correlational relationship changes in one variable accompany changes in another, but the proper test here have not been conducted to show that either variable actually causes changes in another. Thus, all that is known is the relationship between them exists. So, when changes in one variable tend to be accompanied by specific changes in another, the two variables are said to be covariant. So, however, such covariation does not necessarily mean that either variable exerts a causal influence on the other, although it may. So, the number of, for example, baseball games may be increased in the winter, for example. Uh, uh, and the number of mosquitoes tend to covary both increase in maybe in winter or in spring season and decrease in the fall, for example. Yet you would not conclude that mosquitoes cause baseball games or vice versa, even that they have a strong correlational relationship. Correlation research features. In correlation research, your main interest, as I say, is to determine whether two or more variables covary, and if so, to establish the directions, magnitude, and form of the observed relationship. The strategy involves developing measures of the variable of interest and collecting your data. So, correlation research belongs to a broader category called non-experimental research, which also include designs not specifically aimed at identifying a relationship between variables. So, correlation also research involves observing the value of two or more variables and determining what relationship exists between them. So, in correlation research, you make no attempt to manipulate variables but observe them as they are. For example, imagine that you wish to determine the nature of relationship, if any, between pretest anxiety and test performance among students. So, On test day, you have each student rate his or her own level of pre-test anxiety, and after the test, results are in. So you determine the test performance of those same students, and you find your data consists of two scores for each student: self-rated anxiety level and test score. You analyze your data to determine the relationship, if any, between these two variables, and note that both anxiety level and test score are observed as found in each student. So establishing that correlation relationship exists between the two variables make it possible to predict from the value of one variable the probable value of the other variable. So when you use correlation relationship for prediction, the variable used to predict is called a predictor variable, and the variable whose values is being predicted is called the criterion variable. Whether the linkage between these variables is causal remains an open question, and we will see it later. So also, researchers have been studying the factors that contribute to being a bully and being a victim of bullying. For example, we take this example to see that relationship. What is the relationship between playing violent video games and being bullied? So one study investigated the relationship between exposure to violence on online games and cyberbullying among adolescents. And according to the finding of this study, the more an adolescent was exposed to violent online video games, the more likely it was that he or she would be a bully, or both a bully and a victim of bullying. So here you can see how we establish the relationship between two variables. Behavior causation and the correlation approach, given the result obtained of, for example, of the previous study of bullying, you may also be tempted to conclude that increased exposure to or playing of violent video games causes bullying. However, this conclusion that a causal relationship exists is inappropriate, even though the relationship appears compelling. Two obstacles stand in the way of drawing a clear causal inferences from correlational data: the third variable problem and the directionality problem. Let's see this why. The first is the third variable problem. To establish a causal relationship between two variables, you must be able to demonstrate that variation in one of the observed variables could only be due to the influence of other observed variables. In the example that we just now gave for the online video game, you want to know whether increased exposure to violent video games causes increased bullying. However, it is possible that the observed increase in bullying in this study was actually due to another unmeasured variable. Perhaps adolescents who play a lot of online video games also have parents who use a great deal of physical punishment, so they got that violence from the parent but not from the video game. If so, it may be that this increased use of physical punishment and not the playing of violent video games is the actual cause for the increased bullying observed. The possibility that correlational relationship may result from the action of an observed third variable is called third variable problem. This observed variable may influence both of the observed variables, example playing violence video games and bullying, causing them to vary together even though no direct relationship exists between them. So the two observed variables thus may be strongly correlated even though either variable cause changes in the other. So in order to resolve the third variable problem, we must examine the effect of each potential third variable to determine whether it does in fact account for the observed relationship or not. And here we talk about the uh, directionality problem. The second reason, as I say, why it is hazardous to draw causal inferences from correlational data is that even when a direct causal relationship exists, the direction of causality is sometimes difficult to determine. This difficulty is known as a directionality problem. So in our example of these violent video games, we want to conclude that playing violent video games causes bullying. This causal connection seems to make intuitive sense. However, one could also argue just as well that bullies enjoy violence and therefore prefer to play more violent video games than non-bullies. So with a purely correlation study, there is no way to determine unambiguously which way the causal arrow points, and this is another problem. So correlational research, when it is used, why we use correlational research if there is these problems as we just explained? So given the problem of interpreting the result of correlational research, you may wonder why we would want to use this approach then. However, correlational research has a variety of applications, and there are many reasons to consider using it. For example, first, gathering data in the early stage of research. So during an initial exploratory stage of the research project, the correlation approach ability to identify potential causal relationship can provide a rich source of hypotheses that later may be tested experimentally. So it can help you to develop your hypothesis. Therefore, later you collect the data and test this hypothesis whether there is really an effect or no. Second is inability to manipulate variables. For example, in experimental design, variables are manipulated to determine their effect on other variables. So a second reason for choosing a correlational design of an experimental one is that manipulating the variable of an interest may be impossible or unethical. I give you an example. Imagine that you were interested in determining whether psychopathic personality develops when a child is raised by cold and caring parents. So to establish a clear causal connection between the parent behavior toward the child and psychopathic personality, you would also have to conduct an experiment in which the parent behavior was manipulated by assigning infants at random to be raised by either normal parent or cold and caring ones. However, this experiment would be impossible to carry out. Why? Who would allow their child to participate in such an experiment? And because of its potential for inflicting serious harm on the child and ethical as well. So in this case, a correlational design may be only practical and ethical option, because you cannot use the experimental design. Another one is relating naturally occurring variables. The third situation in which you may choose a correlational research design over an experimental design is one in which you want to see how naturally occurring variables relate in the real world. For example, imagine you are interested in whether individuals are more susceptible to suffering from post-traumatic stress disorder after different traumatic events, for example, severe hurricane or flood. So you could address this problem with a correlational study. You could compare the number of those post-traumatic stress disorders, or what we call them PTSD, symptoms a person experience after a hurricane to those experienced after flood. Of course, you cannot manipulate weather condition. You cannot bring the flood yourself. You cannot bring the hurricane yourself. You can only measure them. So you have to wait until a hurricane or flood occurs to include that variable in your study. So result of such a study may be valuable in predicting reaction to different type of traumatic events. So this result could then help to design different treatment methods for the effect of those different events. Then, what are the characteristics of an experimental research? Unlike correlational research, an experimental research incorporates a high degree of control over the variables of your study. This control is used properly, permits you to establish causal relationship among your variables. So, what is experimental research? Experimental research has two defining characteristics: manipulation of one or more independent variable and control over extraneous variables. So an independent variable is the variable whose values are chosen and set by an experimenter or you as a researcher. We call these set values the levels of the independent variable. For example, imagine you want to determine how sleep deprivation affects the person's ability to recall previously memorized materials. To examine this relationship, you may assign participants to one of three groups defined by the number of hours of sleep deprivation. For example, 0 hours, or 24 hours, or 48 hours. These three amounts would constitute the three levels of sleep deprivation, your independent variables. Notice how this strategy differs from addressing this question in correlation study, in which you would simply measure how much sleep in participant receive and then test memory. And the second is to manipulate your independent variable. You must expose your participant to at least two levels of that variable. The specific conditions associated with each level are called treatment of the experiment. So depending on the design of your experiment, the independent variable may be manipulated by exposing a different group of participants to each treatment, or by exposing each participant to all the treatment in sequence. By manipulating the independent variable, you hope to show that changes in the level of the independent variable causes changes in the behavior being recorded. Then another characteristics in the dependent measure or dependent variable. So the variable was the value you observe and measure in experimental design is called dependent variable or dependent measure. If a causal relationship exists, then the value of the dependent variable depends at least to some extent on the level of the independent variable. Its value also depends on the other factors such as participant characteristics, age, gender, level of education. Another way to think about the dependent variable is that its value depends on the behavior of the participant rather than being set by the experimenter. Let's see. Manipulating an independent variable can be simple as exposing one group of participants to some treatment, for example, distracting noises, and another group of participants to the absence of those treatment, there is no distracting noises, for example. So, in this most basic of experimental design, the group receiving the treatment is called an experimental group, and the other group are the control group. The control group is treated exactly like the experimental group, except that it is not exposed to the experimental treatment. So, the performance of the participant in the control group provides a baseline of behavior against which the behavior of the participant in the experimental group is compared. So, control over extraneous variables. The second characteristics of an experimental research is the control over extraneous variable. Extraneous variables are those that may affect the behavior you wish to investigate but are not of interest for present experiment. For example, you may be interested in determining how well the new anxiety therapy experimental group compared to an existing therapy which is control group. Affect test anxiety in anxious students. If some of your participants show up for the experiment drank, they drink alcohol, they are drank, their degree of intoxication become an extraneous variable. This would be especially problematic if more drunk students ended up in one group than in another. So you have some of biasness. If allowed to vary on their own, extraneous variables can produce and control changes in the value of the dependent variables with two rather nasty possible consequences. First, uncontrolled variability may make it difficult or impossible to detect any effect of the independent variable. In our example, the effect of the therapy could be hidden by the effect of the alcohol. Second, uncontrolled variability may produce chance differences in behavior across the level of independent variables. These differences could make it appear as though the independent variable produced effect when it did not. The therapy would appear to work even though the real effect came from the alcohol. So to identify a clear causal relationship between your independent and dependent variable, you must control the effect of extraneous variable. You have here two ways to control this effect. The first way is to hold extraneous variables constant. If these variables do not vary over the course of your treatment, then they cannot cause and control variation in your dependent variable. In the anxiety therapy experiment, for example, you may want to make sure that all your participants are sober or at least intoxicated to the same level. In fact, to the degree possible, you would want to make sure that all treatments are exactly alike except for the level of independent variable. So the second way to deal with extraneous variable is randomize their effect across the treatment. This technique deals with the effect of extraneous variable that cannot be held constant or for reasons that will be explained later should not be held constant. In an experiment assessing the effect of sleep deprivation on memory, for example, it may not be possible to ensure that all your respondents have had identical amount of sleep deprivation. Some may have slept better than others the day before your experiment began, or that their recall abilities are equivalent. The idea is to distribute the effect of these differences across treatment in such a way that they tend to even out and thus cannot be mistaken for effect of the independent variable. For statistical reasons, one of the better ways to accomplish this goal is to use a random assignment of subject to treatment. With random assignment, you assign participant to treatment randomly by means of a table of random numbers of computers, random numbers generated. Random assignment does not guarantee that the effect of extraneous variable will be distributed evenly across the treatment, but it usually works reasonably well. Better yet, it allows you to use inferential statistic to evaluate the probability with which chance alone could have produced differences in performance across treatment, at least as large as those actually observed in your experiment. However, it is done. Control over extraneous variable is crucial to establishing a clear causal relationship between your variable. By controlling variables that may affect your dependent variable, you rule them out as possible alternative explanation for your result. What are the strengths and limitations of this experimental research? The great strength of experimental approach is its ability to identify and describe causal relationship. So this ability is not shared by the correlation approach, whereas the correlation approach can tell you only that changes in the value of one variable tend to accompany changes in the value of the second variable, but the experimental research can tell you whether changes in one variable, the independent variable for example, actually cause changes in the other variable which is dependent variable. So despite its power, this to identify causal relationship, the experimental research has also limitations that restrict its use under certain conditions. For example, the most serious limitation is that you cannot use experimental method if you cannot manipulate your hypothesized causal variables. For example, studies of personality disorders must use correlational approaches to identify possible causal relationship, exposing people to various nasty conditions in order to identify which of those conditions cause personality disorder is not ethical. You cannot do that. So a second limitation of the experimental research or approach entails the tight control over extraneous factor required to clarify, reveal the effect of the independent variable. Such control tend to reduce your ability to apply your finding to situations that differ from the condition of your original experiment. A rather unpleasant trade-off exists, for example, in um, experimental research. As you increase the degree of control, you excel over extraneous variables and thus your ability to establish causal relationship. So you decrease your ability to generalize your finding beyond the condition assessed in your experiment. Now we talk about the internal validity. Whether the general design of your study is experimental or correlational, you need to consider carefully two important but often conflicting attributes of any design, which is internal and external validity. We talk about the internal validity. Much of your research will be aimed at testing the hypothesis you developed long before you collected the data. The ability of your research design to adequately test your hypothesis is known as its internal validity. Essentially, internal validity is the ability of your design to test the hypothesis that it was designed to be tested or to test. In an experiment, this means showing that variation in independent variable and only the independent variable caused the observed variation in the dependent variable. In a correlational study, it means showing that changes in the value of your criterion variable rely slowly on the changes in the value of your predictor variable and not to changes in others, extraneous variables that may have varied along with your predictor variable. So internal validity is treated to an extent that extraneous variables can provide alternative explanation for the finding of the study. For example, Hack and Sandel in 1979, they called this as rival hypothesis. An example of that, imagine that an instructor wants to know whether a new teaching method works better than the traditional method. So I may use the instructor decide, for example, to answer this question by using the new method to teach in the morning section of that particular subject and using the traditional method to teach in the afternoon section. But both sections will be used the same text, cover the same materials, and receive the same test. But the effectiveness of the two methods will be assessed by comparing the average score achieved on the test by the two sections. Now imagine that the instructor or the lecturer conduct the study and find out that section receiving the new method receive substantially a higher average grade than the section receiving the traditional method. So the lecturer concludes that the new method is definitely better for teaching this course, but is that instructor or lecturer justified in drawing this conclusion? So you have that question now. The answer, as you probably suspected, is no, because several rival hypotheses cannot be eliminated by the study explanation, at least as credible as the instructor. Consider the following rival hypothesis. For example, you may ask, the morning student did better because they were fresher than the afternoon student. Or the morning student did better because their instructor was fresher in the morning than the afternoon, so that he can give them a better guideline, a better instruction. The instructor expected the new method to work better and thus was more enthusiastic when using the new method than when using the old one. So since he expected that the new method is better, he give his best to explain in the new method than the traditional one. Students who registered for the morning classes were more motivated to do well in the course than those who registered in the afternoon classes. So these rival hypotheses do not exhaust the possibilities. Perhaps you can link of others because the study was not designed to rule out this alternative. There is no way to know whether the observed difference between the two sections in student performance was due to the differences in teaching method, in structure on CSM, or other factors. Whenever two or more variables combine in such a way that their effect cannot be separated, a confounding of those variables has occurred. So, in the teaching study, teaching method is confounded by all those variables just listed and more. Such study lack of internal validity. So here we say that this study lack of internal validity. So confounding, although always a matter of concern, does not necessarily present a serious threat to internal validity. Confounding is less problematic when, for example, the confounding variable is now to have a little or no effect on the dependent or criterion variable, or when it is now the effect can be taken into account in the analysis. For example, in the teaching study example, it may be possible to eliminate concerns about differences in class meeting times by comparing classes that meet at different times and but use the same teaching methods. Such data may also show that meeting time has only a small effect that can be ignored. If meeting time had a larger effect, you could arrange your study of teaching methods so that the effect of the meeting time would tend to make the new teaching method appear worse than the standard one, thus biasing the result against your hypothesis. So if your reason until favor the new teaching method, that outcome would have occurred despite the confounding rather than because of it. Thus the study may include confounding and still maintain a fair degree of internal validity if the effect of the confounding variable in the situation under scrutiny are known. And also, this is fortunate because it is often impossible to eliminate all sorts of confounding in the study. For example, the instructor in our example might have attempted to eliminate confounding by having students randomly assign the two section meeting simultaneously. This would certainly eliminate those causes of confounding related to any differences in the time at which the section met, but now it would be impossible for the instructor to teach both classes. If a second instructor is recruited to teach one of the section using the standard method, this introduces a new source of confounding in that the two instructors may not be equivalent in a number of ways that could affect class performance. Often the best that can be done is to substitute what you believe to be less serious threat to internal validity for a more serious one. So this is now we have some of the difference, the factors that affecting internal validity. First, we have history. History may confound studies in which manipulate observation, and those observations are taken over time. So, a specific event may occur between observations that affect the result. For example, a study of the effectiveness of an advertising campaign against drunk driving may measure the number of arrests for a drunk driving immediately before and after the campaign. If the police institute a crackdown on the drunk driving at the same time that the advertisement airs, this event will destroy the internal validity of your study. A second one is maturation, which is referred to the effect of age or fatigue. Performance changes observed over time due to those factors may confound those due to the variable being studied. Then we have another one is testing. Then in testing occur when a pretest sensitizes participant to what you are investigating in your study. As a consequences, they may respond differently to post-treatment measures than if there is no pretest were given. Then we have instrumentation. Confounding may be introduced by observed changes in criteria used by observers on instrumental calibration. So if observers change what counts as a verbal aggression, for example, when scoring behavior under two experimental conditions, any apparent difference between those conditions in a verbal aggression could be due as much to the change criterion as to any effect of the independent variable. Similarly, if an instrument used to record activity, for example, of any particular maybe animal, remove this. Then we have statistical regression. Statistical regression threatens internal validity when participants have been selected based on extreme scores and some measures. When measured against score will tend to be closer to the average. So those if students are targeted for a special reading program based on their unusually low reading test score, they will tend to do better on average on retesting even if the reading program has no effect. Then we have a bias selection subject. Bias selection of subject threatens internal validity because subject may differ initially in ways that affect their scores on the dependent variable. Any influence of the independent variable on the score cannot be separated from the effect of pre-existing bias. So this problem typically arises when researchers use pre-existing group in their studies rather than assigning subject to groups as a random. Then we have a final one is experimental morality, which is referred to the differential loss of participants from a group in study. For example, imagine that some people drop out of the study because of frustration with the task. A group exposed to difficult conditions is more likely to lose its frustration intolerant participant than one exposed to a less difficult conditions. Any differences between the group in performance may be due as much to the resulting differences in participant as to any difference in condition. So now we talk about the external validity. What is external validity? Also, a study has an external validity to the degree that its result can be extended, means generalized. That's what we mean about the validity. So the result, as I said, can be generalized beyond the limited research setting and sample in which they were obtained. A common complaint about research using college students and conducted under the, for example, artificial condition of setting or laboratory is that it may tell a little about how college students, for example, in the second year, behave under the condition imposed on them in the much richer arena of the real world. The idea seems to be that all studies should be conducted in such way that the finding can be generalized immediately to real world situation and a larger population. However, as stated by Mook 1983, it is fallacy to assume that the purpose of collecting data in the laboratory is to predict real life behavior in the real world. Mook pointed out that much of the research conducted in laboratory is designed to determine one of the following. First, whether something can happen rather than whether it typically does happen. Uh, Second, whether something we specify ought to happen according to some hypothesis and the specific condition in the lab does happen there under those conditions. The third, what happened under condition not encountered in the real world. In each of these cases, the objective is to gain insight into an underlying mechanism of behavior rather than to discover relationships that apply under normal conditions in the real world. In this, underlying that generalizes to everyday life, not the specific finding themselves. Then we will have factors that affecting external validity. For example, you have reactive testing when a pretest may affect a reaction to an experimental variable. Therefore, it will affect the whole research. Interaction between selection biases and the independent variables. Result may apply only to subject representing in a unique group. Reactive affect the experimental arrangement, for example, artificial experimental manipulation or the subject knowledge that he or she is a research subject may affect the result, and multiple treatment interference where exposure to early treatment may affect responses to later treatments. Internal versus external validity. Although you should strive to achieve a high degree of both internal and external validity in your research, in practice, you will find that the step you take to increase the one type of validity tend to decrease other. For example, a tightly controlled laboratory experiment afford you to relatively high degree of internal validity. So your finding, however, may not generalize to other samples and situations. Thus, external validity may be reduced. Often, the best that you can do is to reach a compromise on the relative amount of internal and external validity in your research. So whether internal or external validity is more important depends on your reason for conducting the research. If you are most interested in testing a theoretical position, as is often the case in a basic research, you may be more concerned with internal than external validity and hence conduct a tightly controlled laboratory experiment. However, if you are more concerned with applying your result to a real world problems, as in the applied research, you may take steps to increase the external validity while attempting to maintain a reasonable degree of internal validity. These issues need to be considered at the time when you design your study. I just mentioned that the setting in which you conduct your research strongly influence the internal and external validity of your result. And what about the research setting? So in addition to deciding on the design of your research, you also must decide on the setting in which you conduct your research. Your choice of setting is affected by the potential cost of the setting. Its convenience, ethical consideration, and research question you are addressing. This all you must take in consideration. The two research setting open for example, social science and psychological research are the laboratory and the field. So, simulation, we have first the simulation where recreating the world in laboratory means that try to make things like as it is in real world. When you choose the laboratory as your research setting, you gain control over extraneous variable that could affect the value of your dependent variable. But however, you take a trade-off when choosing the laboratory. Although you gain better control over the variables, your result may lose some generality. If you are concerned with the ability to generalize your result as well as with controlling extraneous variable, consider using a simulation. In a simulation, you attempt to recreate as closely as possible a real-world situation in laboratory. A carefully designed and executed simulation may increase the generality of your result because this strategy has been used with increasing frequency lately. A detailed discussion we will follow now how we see how this works. You may decide for a variety of reasons to simulate rather than to conduct research in the real world. You may choose simulation because the behavior of interest would not be studied ethically in the real world. For example, creating a panic situation in order to study the ensuing behavior of is an unethical. For example, a study by Board and Codlin 2013 avoided this problem by studying panic in a simulated environment. A virtual room containing a crowd of people and offering only two exits. To establish a familiar route, Board and Codlin 2013 had a participant practice leaving the virtual room via one of the exit. So the researcher varied the distribution of others trying to exit the room equally or unequally distributed between the two exits and the motivation to exit. So in one condition, participants were simply told to exit the room. In the second, they were told no exit. In the second, they were told to exit the room before a time shown on the screen was up. This second condition was intended to simulate getting out of the crowd or the crowded room and the stress. So Bode and Codlin 2013 found that and the stressed participant preferred a familiar route, even if that route was clothed with others. So they did not do so when share was absent. So often researchers choose to simulate for a practical reasons. A simulation may be used because studying a behavior and its naturality occurring condition is expensive and time consuming. By simulating in the laboratory, the researcher also gain the advantage of retaining control over variables while studying the behavior under relatively realistic condition. So bear in mind that the more realistic the simulation, the greater are the chances that the result will be applicable to simulated real-world phenomena. Then we talk about another setting, which is the failed setting. A field experiment is an experiment conducted in the participant natural environment. In a field experiment, you manipulate independent variables and measure a dependent variable. You decide which variable to manipulate, how to manipulate them, and when to manipulate them. Essentially, the field experiment has all the qualities of the laboratory experiment, except that the research is conducted in real world rather than in artificial laboratory setting. An example, consider a field experiment conducted by George Shear, Sandra Smith, and Kristen Thomas in 2009 on whether black and white customers in an upscale shop are treated differently. In the store selling expensive sunglasses. So this group of researchers had either a black or white customer who was working for the researcher. So approach the white salesperson and asked to have the security tag removed from a pair of sunglasses so that he or she could try them on. So the customer then walked to a closet mirror and examine him, or examine that customer in the mirror for 1 minute. So observers in the store, one black and one white, so recorded three behavior. Whether or not the salesperson removed the tag, how much the salesperson followed the customer. For example, 1 equal no following to 5 shadows to the customer. That means just keep beside him. And the degree to which the salesperson stared at the customer. 1 if there is no staring, and 5 it looks over repeatedly or remain stare on more than 4 seconds. So this group of researchers found that in all cases, the salespersons removed security tag from the sunglasses. Then, however, they followed and stared at the black customer significantly more than the white customer. This study suggests that shopping while black, where the black customer are treated with a greater suspicion than the white customer, may be a real problem. Of course, more research of this type would be necessary before we can increase our confidence in this conclusion. So this group of researchers, a field experiment, has all of the feature of the true experiment. An independent variable was manipulated, I mean here the race of the customer, and dependent variables were measured, willingness to remove the security tag, following and staring at the customer. So because this was an experiment, a causal inference can be drawn between the race of the customer and sign of prejudicial behavior. Also, we have another second things is what is the advantage and disadvantage of this field experiment. As with the laboratory experiment, the field experiment has its advantages and disadvantages. Because the research is conducted in the real world, one important advantage is that the result easily can be generalized to the real world, high external validity. An important disadvantage is that you have little control over potential confounding variables. For example, you have low internal validity. In the example just now for Chia et al., field experiment. For example, the researcher could not control the number of customers who were in the store at the time of the experiment. Different number of other customers in the store could differently affect the salesperson reaction to the experimental customer. Additionally, the researcher could not prevent the observers from knowing whether the customer was black or white. The observers may interrupt a salesperson's behavior differently, knowing that the customer was black versus white. Extraneous variables such as these can obscure or distort the effect of the independent variables manipulated in the field experiment. So now we go for a next part where we make a systematic observation. So, assuming that you have decided on a general research topic, a number of factors that may influence your choice of specific variables, to observe and manipulate. Some of them are research tradition, theory, availability of the new techniques, and availability of equipment. So we go one by one. The first is research tradition. If your topic follows up on previous research in a particular area, the variables you choose to observe may be the same as those previously studied. In particular, you may choose to study the same dependent variable while manipulating new independent variables. The second one is the theory. Your decision about what to observe also may depend on a particular theoretical point of view. For example, you may choose to observe behaviors that are seen as important from a certain theoretical perspective. If these variables or other variables have been used in previous research, you probably should use the measure already developed for them. However, the theory may suggest looking at behavior not previously observed, in which case you may need to develop your own measures. Then we have availability of new techniques. Sometimes a variable cannot be investigated because there is no suitable way to measure it. In this case, the development of new techniques may open the way to observation and experimentation. You may want to use the new measure simply to explore its potential for answering your research question. Then availability of the equipment. You are always tempted to adopt measures for which you already are equipped. If the chosen measures provide reasonable answer to your research question, this decision is not then wrong. You are in the right decision. But problems arise when the measure really is not appropriate or adequate for a question being investigated, but is chosen anyway on the basis of mere convenience. If you have chosen a particular measure simply because it is readily available or convenience, you should ask yourself whether it really is the best measure for your question or not. What is the reliability of the measures? So the reliability of the measure concerns its ability to produce a similar result when repeated measurements are made under identical conditions. For example, imagine that weighing yourself several times in a quick succession using an ordinary bathroom scale. You expect to see the same body weight appear in the scale each time. But if the scale is cheap or worn, the numbers may vary by 1 or 2 pounds for every or even worse. So the more variability that you observe, the less reliable is the measure. Procedures used to assess reliability differ depending on the type of the measure. Then we have reliability of physical also measure. So here you assess the reliability of measure of physical variable and such as the height, the weight, by repeatedly measuring a fixed quantity of the variable and using the observed variation in a measured variable to drive the precision of the measure, which represent the range of variation to be expected on repeated measurement. For example, the precision of weighing produced by a given bathroom scale may be reported as plus minus 1.2 pound. A more precise measurement has a smaller range of variation. Then we have reliability population, where for measures of opinion, attitude, and similar variables in which the problem is to estimate the average value of the variable in a given population based on a sample drawn from that population. So the precision of the estimate, which is likely variation from a sample to a sample, is called margin of error. So the result of a poll of registered voters, for example, asking whether the vote or the voter favor or oppose a stronger legislation, for example, on gun control in the United States, may be reported as 41 favor stronger legislation, 54 are against, and maybe 5% are unsure, with a margin of error plus minus 3%. And the last one, reliability judgment, assessing reliability of measures. And here when you have measures or rating by multiple observers. Here when the measure being made consists of judgment or rating of multiple observers, you can establish the degree of agreement among observers by using statistical measure of iterator reliability. Then we have also reliability of psychological tests can be established in several ways. So, assessing reliability of measurement stability of psychological variables such as intelligence, maybe anxiety level, the mood, and so on, poses a special difficulty in that these variables tend to change naturally over time. By the time you repeat measurement of, say, let's say a mood or anxiety level, the underlying quantity being measured in the individual may have changed. So, if so, the measure will appear to be unreliable, even though the changes in measured value reflect real changes in the variable. So, in addition, for various reasons, it is often not possible to administer psychological assessment devices to the same individual as sufficient to number of times to determine the reliability of measurement. Thus, an alternative strategy is needed for assessing reliability of these measures. So the basic strategy for assessing reliability of psychological measures is to administer the assessment twice to a large group of individuals and then determine the correlation. We usually use Pearson R between the scores on the first and the second administrations. So the higher the correlation, the greater the reliability. A test is considered to have a high reliability if the R or Pearson correlation is 0.95 or higher. So you can choose among several methods for assessing reliability of psychological tests, each with a different set of advantages and drawbacks. These include the test, retest, parallel forms, and split half reliability assessment. So to assess retest reliability, you administer the same test twice, separated by a relatively long interval of time to the same individuals. To the extent that the test is reliable, scores on the two administrations of the test will be strongly positively correlated. Then we have, what are the problems of that test retest reliability? Because you administer the same test twice, any changes in score cannot be due to differences in question wording or the use of non-equivalent items. However, this advantage must be weighed against two disadvantages. First, if on second administration, participants simply recall how they answered in the first item on the first administration, the test may appear to be more reliable than it actually is. Second, a participant may change between administration of the test. Although changes in the test scores may accurately reflect this difference, they can also make the test appear less reliable than it actually is. For these reasons, the test-retest method is best for assessing stable characteristics of individuals such as intelligence. The variable being assessed by the test is unlikely to change much between administrations, and administration can be spaced for enough apart that participants are unlikely to remember much about their previous response to the test. Then also another drawbacks or problem, you can avoid them by remembering of previous responses by assessing parallel forms reliability. So this is the same as test-retest reliability, except that the form of the test used on the first administration is replaced on the second administration by a parallel form. A parallel form contains items supposedly equivalent to those found in the original form. This assesses the same knowledge, skills, and so on, but use somewhat different questions or problems, which eliminates the possibility that on the second administration the participant was simply recalling his or her answer on the previous occasion. Then, however, in the if the items of the forms are not truly equivalent, differences in the test performance due to this non-equivalent may also reduce the apparent reliability of the test. So in addition, the parallel form method still suffers from the possibility that quantity measured may have changed since the first administration, thus making the test appear less reliable than it is really. You can avoid the problem also caused by changes between administration in the quantity being measured by choosing split half reliability. So here the two parallel forms of the test are intermingled in a single test and administered together in one sitting. The response of the two forms are often separated and scored individually. Because both forms are administered simultaneously, the quantity being measured has no time to change. However, the need to use alternate forms in the two halves introduces the same problems found in the parallel forms method, that of ensuring that the two forms are in fact equivalent. This method for assessing reliability of psychological tests apply equally well of assessing reliability of questionnaire design for distribution in a survey for any social science topic. Then, what is the accuracy of the measure, which is also a very important term of accuracy describe a measure that produces results that agree with a known standard. For example, as we say, a bathroom scale is accurate if indicate 50 pound when a standard 50 pound weight is placed on it. 100 pound when a standard of 100 pound weight is placed on it, and so on. A thermometer calibrated in degrees Celsius is also accurate if it reads 0 degrees when tested in a slurry of ice and 100 degrees when placed on boiling water. So both tested under sea level or, for example, air pressure. So a counter is accurate if the number of events counted equals to actual number of events that occurred. So determining accuracy is hampered by lack of precision. Your measurement may not agree with a known standard each time that you make it. However, measurement may still be accurate in the sense that value observed agrees with the standard on average. So thus you can determine accuracy by measuring the standard a large number of times and computing the average. The measure is accurate if the average value equal to the value of the standard. Any difference between this average value and the standard value is termed as bias. Bias can be overcome either by adjusting the measuring instrument to eliminate it, or if this is not possible, by mathematically removing the bias from the measured value. We have also here in psychological measurement standard are rare, and therefore the accuracy of measure cannot be assessed. This does not mean that you should ignore accuracy issues altogether. For example, a non-standard introvert exists against which to assess the accuracy of a measure of an introversion or extraversion personality variable, for example. In such a case, test score may be standardized by statistical methods to have a specified average value in a given population and a specified number of variability. So now we talk about validity of a measure. So you should always be concerned about the validity of any measure, but in social science and specifically in psychology, the topic comes up most often when discussing tests designed to measure social sciences or psychological attributes. In this context, several types of validity have been defined, each requiring somewhat different operation to establish. For example, the face validity. This face validity describes how well a measurement instrument, example, test of intelligence, appears to measure, judging by its appearance what it was designed to measure. So, for instance, a test of mathematical ability would have face validity if it contained math problems. Face validity is a weak form of validity in what an instrument may lack face validity and yet, by other criteria, measure what it is intended to measure. Nevertheless, having a good face validity may be important if those who take the test do not perceive the test as valid. So they may develop a negative attitude about its usefulness. Then we have content validity, has to do with how adequately the content of the test sample, the knowledge, skills, or behavior that test is intended to measure. For example, a final exam for a course would have content validity if it adequately sampled the materials taught in the course. So an employment test would have content validity if it adequately sampled from a large set of job related skills. Finally, a test designed to measure assertiveness would have content validity to the extent that adequately sampled from the population of all behaviors that would be judged as assertive. Then we have a criterion related validity where reflect how adequately a test score can be used to infer on individual value on some criterion measures. To determine the test criterion related validity, you compare the values inferred from the test to the criterion values actually observed. Criterion related validity includes two subtypes. You assess the concurrent validity, and if the score on your test and the criterion are collected at about the same time. Then you have to assess predictive validity by comparing the scores on your test with the value of criterion measure observed at later time. A high correlation between these measures indicates a good predictive validity. Predictive validity indicates the ability of a test to predict some future behavior. Then the last one, we have construct validity. Applies when a test is designed to measure a construct which is viable. This not directly observable that has been developed to explain behavior on the basis of the same theory. For example, include such variables as intelligence, self-esteem, and achievement motivation. To demonstrate the construct validity of a measure, you must demonstrate that those who score high or low on the measure behave as predicted as by theory. For example, those who receive low or high score on the intelligence test should behave in the way people of low intelligence would be expected to behave. So, as predicted by the theory of intelligence on which the construct was based. Then we talk about the acceptance of an established measure. Although you do not have to spend precious time validating an established measure, it may not be suitable for addressing your research question. So an alternative to using established measure is to develop your own. This alternative has the advantage of freeing you from previous theory. In fact, the a successful new measure may shed new light on an old phenomenon. However, you should evaluate its reliability and validity. This may mean testing reliability and validity before you use your new measures in your research. Alternatively, you can use your measure in your research and demonstrate its reliability and validity based on your result. But a danger with this later strategy is that if the measure has problem with reliability or validity, the result of your research will be questionable. Because demonstrating the validity, reliability, and accuracy of a new measure can be time consuming and expensive. Using measures that are already available, especially if you are new in the research area, is advisable. So now we talk about type of scale measurement. So we have a nominal scales where the variables whose values differ by quality and not by quantity. Example, gender, male or female. Values of variable have different names but no ordering or values in implied. One can count for number of observation falling into each category, but one cannot apply mathematical operation on nominal values. Then we have ordinal scales, the higher scale of measurement than nominal scales. And different values of variables can be ranked according to quantity. Example, high, moderate, and low self-esteem. Mathematical operations are likely to produce misleading result in that scale. Then we have interval scale, where the scale of measurement on which the spacing between value is known. For example, rating a book on a scale ranging from 0 to 10. Has a 0 point that does not indicate the absence of the quantity. But you can apply mathematical operation and cannot make ratio judgment. The strongest one is the ratio scale, where similar to interval scale but with a true 0 point. For example, number of lever press or presses can apply mathematical operations and can compare the two ratios. Now we talk about factors that affecting your choice of scale and measurement. The first, you should consider that at least 3 factors when choosing a scale of measurement for a given variable. The informant yielded, the statistical measure you would like to apply to the data, and if you expect to apply your result directly to the natural setting, the ecological validity of the measure. So we start about the information yielded. One way to think about the 4 scale of measurement described earlier is in terms of the amount of information each provide. The nominal scale provides the least amount of information. All you know is that the value differs in quality. The ordinal scale adds crude information about quantity. You can rank the order of the values. But the interval scale refines the measurement of a quantity by indicating how much the values differ. But finally, the ratio scales indicate precisely how much of the quantity exists. When possible, you should adopt the scale that provides the most information. Then we have a statistical test. As noted by Stephen 1946, argues that the basic scale of measurement of a variable determines the kind of statistic that you can be applied to the analysis of your data. Typically, the statistic for nominal and ordinal data are less powerful. Example, less sensitive to a relationship among variables. Then are the statistics used in interval or ratio data. One practical level in this means you are less likely to detect statistically significant relationship among variables when using nominal and or ordinal scales of the measurement. So now we talk about experimental bias. The participant is not the only potential source of bias in the experiment. The experimental can also sometimes unintentionally affect the outcome of an experiment. So, expectancy effect here emerge when a researcher reconceived ideas about how participants should behave are subtly communicated to subject and in turn affect the participant behavior. I give you an example here. For example, a study by Rosenthal in 1976 report a perception experiment in which the independent variable was the information provided to students acting as an experimenter. Some students were taught that according to the previous rating, their participant should perform well. Others were taught that the participant would probably perform poorly. So the student experimenters also were told they would be paid twice as much if the result confirmed the prior expectation. So Rosenthal reported that establishing the expectancy led to different behavior on the part of participants in the two experimental groups. So he pointed out that such expectancy effect may be a problem in not only experimental research but also survey research and clinical studies. In demonstration of facilitated communication, facilitators expected their severely impaired clients to communicate by selling out words using supported hands and wittingly guided their client hand to spell out their own ideas. A second source of experimental bias occurs when an experimenter unwittingly treat participants in a different experimental group in such a way as to confirm the hypothesis being tested. For example, the experimenter may speak more distinctly when presenting verbal stimuli to a group that is expected to perform best on a test of verbal memory. These two sources of experimental bias threaten both internal and external validity. If your behavior becomes a source of systematic bias or error, then you cannot be sure that the independent variable caused the observed changes in the dependent variable. So external validity is threatened because the data obtained may be idiosyncratic to your particular influence. Then also because the experimental bias can pose such a serious threat to internal external validity, you must take steps to reduce this bias. You can do this by using a blind technique. In a single blind technique, the experimenter does not know which treatment a subject has been assigned. For example, in experiment on the effect of children watching violent television on aggression. Children could be randomly assigned to watch either violent cartoons or non-violent cartoons. The measure of aggression could be the number of aggressive acts a child engages in during free play on the playground. In a single blind experiment, the observer watching the children do not know the condition to which the children were assigned. Then we use double blind. So in the double blind technique, neither the experimenter nor the participant know at the time of the testing which treatment the participant are receiving. If you are interested in testing the effect of particular drug on learning abilities, for example, you would give some participant the active drug and some placebo, perhaps an injection of a saline solution, for example. The participant would not know which treatment was being administered, and thus reducing the possibility that the participant expectations about the drug would affect the result. Furthermore, you would have an assistant mix the drug and label them arbitrarily with some code such as A and B. As the experimenter, you would not be told which was the active drug and which was the placebo until after the experiment was completed and the data were analyzed. Thus, neither you nor the participant would know that the time of testing which treatment the participant was receiving. Neither your expectation nor the participant could systematically bias the result. So another method of reducing experimental bias is to automate the experiment as much as possible. In a memory experiment, you could present your stimulus items and time their presentation accurately using a personal computer. The interval between stimulus presentations would be held constant, avoiding the personality that you may present the stimuli more rapidly to one group than the other. You also could automate the instrument by using a recorded version of the instructions. All participants would thus be exposed to the same instruction. Automation is more fully discussed later in the coming topics. So, detecting and correcting problems. No matter how carefully you plan your study, problem almost inevitably crop up when you begin to execute it. A two method you can use to minimize this problem and ensure that usefulness of the data you collect are conducting a pilot study and adding manipulation check. So in pilot study, is a small-scale version of the study used to establish procedures, materials, and parameters to be used in a full study. Many pilot studies are designed from the ground up as a pilot studies intended to provide useful information that can be used when real study gets underway. Pilot studies also can save tremendous amount of time and money if done properly. Perhaps you intend to conduct a large study involving several hundred participants in order to determine which of the two methods of teaching works best in introduction in a course. As part of the study, you intend to hand out a large questionnaire to the student in several classes. Conducting a small pilot study uh, uh, in which you hand out the questionnaire to students is only a couple of classes may turn up inadequacies in your formation or formulation of question, inadequacies that lead to a confusion for misinterpretation. Finding these problems before you train instructor in the two teaching methods, have them teach a full tense and then collect the questionnaire for, let's say, 2,000 students is certainly preferable to finding the problem afterward. So pilot studies can help you clarify instrument, determine appropriate level of independent variables to avoid range effect, and determine the reliability and validity of your observational method, and work. They also can give you a practice in conducting your study so that you make fewer mistakes when you do it in real. For this reason, pilot studies are often valuable. Then we have manipulation checks. In addition to the dependent measures of the behavior and the study, you should include manipulation checks, which is simply test whether or not your independent variables had the intended effect on your participant. They allow you to determine if the participant in your study perceived your experiment in a manner in which you intended. For example, if you were investigating the impact of person attractiveness on how his or her work is evaluated, you might have participants evaluate an essay attributed to either an attractive or an unattractive. So this could be done by attaching a photograph of the attractive or unattractive person to an author profile accompanying the essay. So, as a manipulation check, you could have participant rate the attractiveness of the author on the rating scale. So manipulation tech can also provide you with information that may be useful later when interpreting your data. If your experiment yielded a result you did not expect, it may be that participants interpreted your independent variable differently from the way you thought they would. So without manipulation check, you may not be able to properly interpret surprising effect. So manipulation checks may also permit you to determine why an independent variable failed to produce an effect. For example, they may show that you did not effectively manipulate your independent variable. A set of measures closely related to manipulation checks are those asking participants to report their perception of the entire experiment. So factors to be evaluated may include their perception on the experimenter, what they believe to be the true purpose of the experiment, the impact of any deception, and any other factors you think are important. So unlike manipulation checks also, these measures help you to interpret your result and establish the generality of your data. If you find that a participant perceive your experiment as you intended, you are in a better position to argue that your results are valid and perhaps apply beyond the laboratory test. So for that, I think we come to the end of today's lecture class. It was a little bit lengthy, but it was full of information. And here I would like to emphasize that by understanding all these concepts, now you are ready for quantitative research, whether it is correlational analysis or cause effect analysis, or using experimental by using lab or using simulation. So you are already now have all the component of this quantitative research, and what are the basic steps, and what are the problem you may face, and how to solve all those problems, and how to establish a robust and a solid research design and instrument. If you still have any doubt or you have any question, please keep your comment in below, and I will try to address all those comments, those questions as soon as possible as I can. Thank you very much, and I will see you for the next lecture class, and I hope that you enjoy these classes. Thank you very much.